Hello, good morning, good afternoon, good evening, and good night. Yeah, I'm Mr. Mohan sir, physics master from Hyderabad. Today we are going to discuss about the Coulomb's inverse square law in the vector form. Coulomb's inverse square law. In vector form. Yeah, we know very well that Coulomb's inverse square law. The force of attraction or repulsion between the two charges. Q1, Q2 are the two charges. The force of attraction or repulsion between the two charges is directly proportional to the product of the charges. Q1, Q2. Force is directly proportional to the product of the charges. F is directly proportional to Q1, Q2. And force is inversely proportional to the square of the distance. It is inversely proportional to the square of the distance. So based on that concept, we are now proving for the vector law, for the inverse square law, how we can write it in the vector form. Now consider two charges, Q1, Q2, they are at some distance. Let R be the distance between them. Q1, Q2 are the two charges in the space. To the respective to the coordinate system, we are considering for the coordinate system. Now from the origin, the position vectors are taken. The position of the particle between these two coordinate axes. R1 is the position vector from the origin, and R2 is the position of the particle, position of the charge, point charge Q2 from R2 distance from the origin. Now if you take the repulsive forces between the two similar charges, like charge repulse, unlike charge attracts. So this, because of the second charge, the force is acting on the first charge in this direction, repulsive force. So force on the first charge to the, because of the second charge, repulsive force is acting in this direction. And because of the first charge, there is a force acting on the second charge. Force due to the second charge, due to the first charge, because of the first charge. And if you take the distance, direction, so from here the distance to this charge is taken as distance taken from here, second charge is the distance in this direction, second charge on to the first charge distance is R12 to the second charge from the first charge R12. And same similarly, we are taking the first charge onto the second charge distance. First charge onto the second charge distance is R12. Here R21 means distance from the second charge to the first charge. And here the distance from the first charge onto the second charge. We are taking the distances. Now you know very well that the Coulomb's inverse square law, F is equal to Q. K means a proportionality constant, 1 by 4 pi epsilon naught. Here K is equal to taken as 1 by 4 pi epsilon naught we are taking. This taking as a constant value. That is the permittivity of the medium. The medium in which the attraction force or repulsion force is existing. The capacity of the medium to allow this attraction or repulsion charges, attraction or repulsion forces through the medium. The capacity of the medium is called as we are calling it as the permittivity of the medium, permittivity of the free space or any other medium. According to the K value is a constant of the now K value Q1 Q2 by R square. Your distance, we are considering the distance here. Okay, distance. And we are taking the direction. This is the magnitude, Q1, Q2 by R square is the magnitude, and we are taking a direction. You know how to take the direction with the help of a cap, R cap. R cap is that is considered as the direction, magnitude and direction for this vector. Now, if you remove this direction in terms of the vector form, we have to take the vector to its magnitude. Vector to its magnitude is considered as a unit vector. So unit vector in terms of this vector and its magnitude. Now I am writing this magnitude here. When you add this here, it is becoming square. This square get multiplied with the remaining distance. Then K into Q1 Q2 by R1 to Q. This is the force from second onto the first one. This is the force acting on the second one to the first one. The same similarly we are observing this side. Here force is on the first particle, first charge due to the second charge. K into Q1 Q2 by, that is the distance taken from the second charge to the first charge distance with a unit vector. Unit vector gives the direction. This is the magnitude for this vector force. Magnitude and direction. Now the direction can be written as R21 vector to its magnitude. You can know that the magnitude of a vector can be written here in this direction. Here it is given as square of the distance, and the magnitude of that distance can be taken as R2. Now what we are observing here? Just we are observing here. Both are looking similar. Both the forces are looking similar forces, equal forces. But one is acting in this direction, another one is acting to the other side, left side. To the right side and left side, these two forces are equal forces. They are equal forces, but they are in the opposite direction. So two equal forces and opposite forces acting on the charges. That is the repulsive forces. They are repulsive forces. So this minus sign indicates it is a repulsive force. The force in the opposite direction. Now consider the magnitudes. So neglect the sign and take only the magnitudes. So the magnitude of these two forces, here we are considering the magnitude of these forces, is the total force, that is the force of one direction. Okay, either it may be a repulsive force between the like charges. So the repulsive force between the like charges is given by K into Q1 Q2 by R cube, vector R cube R vector. This is the vector form. This we are writing in a vector form. So the vector form of the equation, here we are writing it as, the two forces are similar forces. Here. So these two similar forces can be written in the vector form. It is K into Q1 Q2 by R cube, vector R cube to the vector. This is the equation in the vector form. This is in the equation of the vector form and without considering the magnitude. Okay children, all of you take into account.